Everyone, and welcome to lesson 11.4. Today we are going to talk about the volume of spheres and hemispheres. So before we get started, I want to talk to you about typing into your calculator things to the third power. So a reminder, in order to type something to the third power, we want to use this little caret icon. And we could type to the third so that we would get our answer here of 1728 for that value. Have you try one on your own. And then same idea for the cube root. Now, a couple different ways to do this. On a graphing calculator, what you are going to do is you have two options. If you go underneath the math menu, you're going to notice option 4. If you select that, will allow you to take the cubic root of something. So 4096, we could see it that way. Another option you have is to type 3. And then again, under the math menu, option 5, that's going to take, again, the cube root of a value. Those of you with a non-graphing calculator, you would hit the second button. You're going to hit 3 first, then the second button, and then that little icon with the X there so it knows you're taking the third root of something. So again, we have this one that is 16, and then take the cube root on your own of option D. All right, now today we're going to talk about volume of spheres. And the volume of a sphere is 4/3 times pi times your radius value to the third power. And then the volume of a hemisphere is just 2/3 pi r to the third power. And again, why is it 2/3 versus 4/3? Well, a sphere is double a hemisphere. So if we take half of the volume of our sphere, we will get the hemisphere, and 1/2 times 4/3 would reduce to be 2/3. So again, on your calculators, we've talked a lot about typing this in. You could just type 4 divided by 3 into your calculator, and then again, r to the third power. So let's look at finding the volume of a couple of these. So we have the first one here is a sphere with a radius value of 4. So we're going to type in 4/3 times pi times our radius value to the third power. And again, we want to round to the nearest tenth on this one. So again, we can just type this in as 4 divided by 3 times our pi, because we're rounding here, and then times 4 to the third power for about 268.1 cubic centimeters. And then on the second one, notice our radius this time is 4 and 3/4. A reminder, 3/4 is the same thing as saying 0.75. So we could say 4.75 instead of 4 and 3/4. So again, we'll take 4/3 times pi times that radius value of 4.75 to the third power for a total this time of about 448.9. Again, that's going to be inches cubed. All right, now our next one is going to ask us to pump up a beach ball. And notice this time a little bit different because they're asking us for the exact value. So when we type in 4/3 times pi times our radius value cubed, we want to use the exact value. So reminder, do not type the pi in your calculator because that will give you an approximated answer. And instead, we're just going to type 4/3 times 2 to the third power. And we'll notice it's about 10.6 repeating. And we want to turn this into a fraction. So on the graphing calculator, math, enter, turns this into 32/3. Reminder, your pi goes with that, either in the numerator or next to it. And again, feet cubed. Those of you with a non-graphing calculator, you will hit the second button, ABC, to turn it into a fraction. All right, on the back, there is one for you to try. This time you are given the diameter and you want the exact value. All right, now for questions 4 and 5, we are back to rounding to the nearest tenth. This time we are looking at different hemispheres. So on this first one, we have 2/3 times pi times our radius value cubed. So 2/3 times our pi value, because again, we are rounding this time, times that radius value of 3.2 to the third power, we get 68.6. And then this time they gave us a diameter, so we have to be careful. We want only the radius. On this one then, 2/3 times pi times that radius value of 1.5 to the third power, 7.0 or 7.1-ish on that. Now, there is one for you to try. This time you have a bowl that is shaped like a hemisphere given this radius. What is the volume that the liquid can hold? All right, now occasionally they are going to ask us to work backwards. This time we are going to try and find the radius and the diameter of each sphere and hemisphere. So notice on this first one, we are given the volume is 31,059.35. And this is a sphere, so we know that this volume equals 4/3 times pi times your radius cubed. Well, step one in this is that we want to get rid of that 4/3. So what we can do is we can take the 3,000 or the 31,059.35, and to undo this division by 3, we can multiply by the 3, and then to undo that multiplication by 4, we then divide by 4. So right now we have that 23,294.5125-ish is going to equal, 5125-ish equals pi times our radius cubed. Well, our goal is to get that radius value by itself. So we can divide both sides by pi. And right now, this 7,414.8 with some extra decimal places equals our r cubed value. So like we talked about in the warm-up, we now want to take the cube root of this. So again, either option 4 or 3 and then option 5, we want to take the cube root of this answer so that we get about 19.5 as our value of our cube root, which means the diameter is double that for a total of 39 for that. Now, what about if we have a hemisphere? Well, a hemisphere has a volume, of 2 pi. So we're going to, 2/3 pi r cubed. So we're going to take our volume and set it equal this time to just 2/3 times pi times r cubed. So again, we're going to start this off. We're going to take that value of the value of the volume, and we are going to multiply it by the 3 to get rid of that. So we have 935.19 equals 2 times pi times your radius cubed. Well, next we need to divide over first the 2 and then the pi to get a radius cubed value of 148.8401112. Again, we can take the cube root of that by typing 3. Math menu option 5, that's one way to type it. And again, when we cube root that answer, we get about 5.3 as the value of the radius, which means our diameter is about 10.6. All right, last page talks about the cross sections of our spheres. Now, anywhere we slice a sphere, we are going to get a cross section that is circular. However, the biggest cross section is what we call the great circle, and that's going to cut right through the center of your sphere, and that'll be the biggest cross section, the biggest circle. A reminder to find the area of a circle, aka our cross section. Each one you would take pi times the radius squared. Circumference is 2 pi r. So on this next one, they are saying that we have a plane that intersects the center of a sphere that has a volume of 17,157-ish. And we want to know the area of that cross section, aka the area of that circle, will be our final answer. Well, first things first, in order to get the area of a circle, we need pi times the radius squared. We don't have the radius. We are instead given the volume. So first things first, we are going to work backwards to solve for that radius value, just like we did in the previous problems. So again, we're going to take that value of the volume that they are giving us. This time that's 17,157.285. And we are going to multiply that by the 3 because now this 51,471 is equal to 4 pi r cubed because we multiply both sides by that 3. Next step is we are going to divide by the 4, and then we can also divide by the pi so that we get r cubed by itself. It's 4,096, and then a whole lot of zeros after, right? Now, last but not least, again, we have to take the cube root. So for many of you, you're going to hit 3, math button, option 5, so it plugs that in for you. And then that cube root of 4,096 is right about 16. So that is our radius value. Now that's a lot of work and we want that to be the answer. However, the question is asking us for the area of this cross section. So we're going to take pi times that radius value squared. And when we round to the nearest tenth this time, pi times our radius value of 16 squared is about 804.2. All right, it is your turn on this last one. You are working backwards first to solve for the radius. And then again, your final answer should be the area of your circle after plugging in your R value. Thanks everyone for watching. I'll work more with these in class.